Good afternoon, ladies and gentlemen, and thank you for joining us at today's Gas Industry Award webinar organised by EUA and iGEM. My name is Simon Trollope. I'm the Head of Development and Knowledge Delivery here at iGEM, and it's my pleasure to host this afternoon's session. Today's webinar is going to focus on the Project of the Year category. Just so we have no surprises, the presentations are in no particular order, and the winner will be announced on the 18th of May at the Gas Industry Awards, and more of which a little bit later. Before we begin, let's just go into a few sort of notes on housekeeping. We are using Teams, and thanks for those of you for switching over from what we were planning to, where we had a few technical issues. So if you haven't done it already, can you switch off your videos and microphones during the presentations? To pose questions, if you can use the chat function, which is at the side, probably at the top of your screen in terms of the features. If you can't use the chat, you can just raise your hand and we can come to you if you do have a question that you'd like to ask of one of the presenters. We will be taking questions at the end of each of today's presentations. And just to let you know, we are recording today's session, and a recording will be made available to you shortly after today's event. So this year we're looking at, or this week we're looking at the Project of the Year award, and the organisation shortlisted for this category have undertaken a programme of work individually or collaboratively to address one or more of the challenges that are currently facing our industry. So the judges, when they met last year, assessed this category on the following. They were looking for evidence that the project addressed a genuine challenge associated with planning, construction, operation and maintenance of gas works, either now or in the future. Whether or not the project was a proposed solution that is possible and scalable at reasonable cost. Whether there was the adoption and use of new innovative technology or new ways of working. Clearly looking at whether or not there were measurable results and outputs, and what contribution the project was making to the decarbonisation of the gas network by reducing the environmental impact of activities. So the shortlist for this particular category is quite large. We actually have 5 projects we'll be hearing from this afternoon. We'll be looking to hear from the Albert Course gas mains replacement, which was delivered by tRIIO. We'll look at the asset investment planning project undertaken by National Grid Gas Transmission. The Gas to the West project, which was delivered by SGN Natural Gas in collaboration with Mutual Energy. Green City Vision, undertaken by Wales and West Progressive Energy in collaboration with Scottish and Southern Electricity Networks and UK Power Networks. And finally, the OSS project, undertaken by Lagoni Engineering in collaboration with National Grid. So without any further ado, let's move on to the first of today's speakers. So first, I'd like to introduce Donny White, who's the director of tRIIO, and he's going to present on the Albert Court gas mains replacement project. This project completed gas mains replacement work on Albert Court, which is a Grade 2 listed multi-occupancy building adjacent to the Royal Albert Hall, and this project was done on behalf of Cadent. So I'd now like to hand over to Donny, who will share with us details of their project. Donny, the floor is yours.
Thank you, Simon. Can you see my screen okay?
Yes, that's fine.
Brilliant. Okay, thank you. Good afternoon, everybody. As Simon introduced me, I'm Donny White. I'm the director of tRIIO, and I'm joined to my right-hand side, socially distanced by Terry Penny, who's the head of operations, who actually who managed this project for us. So delighted to be shortlisted. And I think as part of our submission, I hope we ticked quite a lot of the boxes you're looking for as part of that process. So the Albert Court mains replacement, for anybody that's been to the proms will recognise Albert Court on the left-hand side there, and on the Albert Hall, sorry, on the left-hand side, and to the right-hand side is Albert Court. A different angle of Albert Court is that splendid building as it's shown on the screen. So tRIIO itself, for those that aren't aware, we are an unincorporated joint venture between Morrison Utility Services and Scansby UTA. We operated through the whole RIIO-1 period from 2013 through to 2021, and as part of that brief, we replaced something over 8,000 kilometres of gas main across both the east of England and North London networks. And one of the projects we undertook was a project to replace an ageing gas main at Albert Court through and the infrastructure of the building itself, it's 8 floors high, 2 floors below ground level. There's 102 dwellings in it, and you can probably tell by the address, location, fairly plush dwellings, and priced between about £3 and £25 million each. As part of the context, tRIIO normally does around 600-700 MOBs or multi-housing building projects each year, and this is one of the flagship projects we completed. So the scope of work for Albert Court itself, it was an employer-nominated mains replacement project. It carried over from prior to RIIO-1 actually, within the old Gas Alliance days, and it was there's high-risk mains with a high history of leakage, and therefore had various temporary repairs. It wasn't G5 compliant, and therefore the continuity of supply was absolutely paramount, because if it was cut off by any of the escapes, then it wouldn't be able to be recommissioned in any short order. So it took quite a lengthy time to get to the scope, a position where we had the scope understood. And as part of the handover, we were asked to survey, design in accordance with G5, construct, test and commission all replacement risers and laterals within Albert Court. There's an in-ground main PE leading to 4-inch steel entering through the basements from Prince Consort Road. We had to provide rise and lateral solutions within 10 light wells to all of the dwellings. That involved about 1.2 kilometres of pipework replacement and replacement and upgrading of either existing valves, meter installations and outlets. We also completed the civil work reinstatement, and with a dwelling 8 floors high and 2 floors deep, there was various working at height solutions, i.e. scaffolding. Just a little bit of a montage of, again, further pictures of the exterior of Albert Court, but just to get a flavour of the sort of dwellings that we were working in. You see they're fairly plush and represent that £3 to £25 million cost per dwelling. Within the scope, and the reason this project took so long to get off the ground, I pass over from prior to 2013, was there was quite some significant construction challenges. One of them being the building history and significance. Albert Court is a Grade 2 listed building, built between 1890 and 1900, and designed by a guy called Frederick Hemmings, for those that know him. The curves in the building itself was designed to complement the Royal Albert Hall, you see in the bottom right-hand side, and as well as the existing Royal Albert Hall mansions. The public body that protects England's historic environment is Historic England, and we had to go through a process of getting some quite significant permissions over the line with Historic England, and as well as that, there was full planning permission required from the City of Westminster. One of the edicts around Historic England, which we'll come back to the solution is where we got to iteratively later on, was that as part of the design, we had to land our entry points to each of the dwellings within 300 mil of what the planned approval was. And clearly we couldn't do that without some innovative solutions. A key part of the approvals is the conservation of Albert Court's authentic exterior, so we couldn't work on the outside of the building, we had to work within the inner light wells. The management company that supports Albert Court themselves, we're looking for the continued supply. Clearly, if you're spending multi-million pounds on a residence, you would want gas for what you're spending there. We also had some significant challenges around access through confined space and restricted access to lights and scaffolding, equipment, plant, people into the construction area. We also had to allow for future development of the basement area, so we had to work closely with the management agent to make sure that they were doing some further flats in some of the basement area, putting in a swimming pool. So we needed to future-proof that, and in fact, we put in an additional valve, a T for a valve, so that they could operate the swimming pool in the future. With that size of property, there's always ongoing building work, so our build plan had to deconflict with anything else that had gone on at the time. Likewise, the light wells are an absolute, it's almost like an echo chamber or a cave for noise. So it was important that we had attenuation in place that restricted noise. The other challenge was that although those are very expensive properties, quite a lot of them are lords and ladies, foreign diplomats, etc. So quite a lot of them are vacant most of the year round. So getting access to them to complete our works was a challenge. In addition to that, we needed to make sure we had dedicated and full-time project management. So with a project that has been carried over from early 2000s, we looked at how we could innovatively meet the requirements of this build. And as part of that, we looked at a BIM model. So during pre-construction, we done a scan to BIM exercise and produced a BIM model. And that represented the architectural surface, structures and services. We were able to complete that design of all the gas mains, pipe risers, etc., and use that to produce the project timeline. We also drew off the quantity of materials, etc., and the exact locations of entry points. So a sample of the BIM model images are shown here, and as part of that BIM modelling, we actually shared that and done a fly-through with all the light wells, all the access points, with Historic England, with the management company, with the City of Westminster, and all affected stakeholders. And there's absolutely no doubt about it that got us the approvals over the line. If we hadn't have done that BIM modelling, that would not have happened, and we would have not constructed that project. The other extract from the BIM was clearly the construction drawings, which, as I mentioned earlier on, is absolutely paramount that the entry points were as per plan, and we managed to do that. Every single one was within the 300 mil tolerance, so absolutely important that with construction drawings that absolutely reflected the existing site and where the proposed infrastructure was going. So in terms of the milestones of the project, we got it at the start of 2013, or it was mooted at the start of 2013. It was 2018 before we got into collectively with ourselves and Cadent around project design and planning, done some risk workshop, and then in early 19 went through project scope, through the project budget, and went through the construction approvals. We commenced in April 2019, and absolutely delighted that on the 26th of November we completed it on time. In fact, we completed it a month early. In terms of cost-wise, we were 18% less than the budget, with no safety incidents whatsoever. And as part of a 2-day client audit, we got 100% pass, so very, very significant. I think one of the telling points, though, was a quote that we've got from a building manager, a guy called Tim Greenwood, who deals with a lot of the trades and lots of the interfaces on behalf of the management company. And his quote was, "Of all the works completed in Albert Court in the last 10 years, you have been the most well-organised and delivered ahead of programme." And in my mind, there's absolutely no doubt about it. The catalyst to that was the innovative solution we used around the BIM modelling in this environment. So the final as-built pictures, they're quite discreet actually. When you look on the left-hand side, that's an inner light well. Our gas risers were running out in the black pipe on the outside, fairly discreet for what they are. There's nothing in the exterior of the building. In addition, the middle picture shows the valve that we've left. That's the basement entry. So very, very confined space, confined area. We've left a T and a valve there for the future development. Special thanks to the team, particularly Ian Penny that ran the job, project manager on the job. We wouldn't have completed that on time without Ian's diligence to the process. In addition, Matt Williamson for the pre-construction activity. So I'm mindful of time, the hour we've got. There's a lot more detail behind Albert Court. Absolutely more than willing to take any calls separately on. But in the meantime, if anyone's got any questions they want to ask now, I can't see the chat function, Simon, because I'm presenting. I don't know if there's any come up.
No worries. I can ask my questions myself. If obviously, if you do have any questions, if you can put them in the chat, and I'll pick those up. I think one of the key things you talked about, Donny, was the importance of obviously using BIM. I suppose, how often did you use BIM before to go through that approach as a team? So
we've used it on some of the civil engineering projects we've done within tRIIO, but this would be the first one we've used on what we call a MOBS, or rise and lateral. We normally don't use BIM. We've used it on a couple since, and I think it's about around cost effectiveness. And when we're doing 600 or 700 projects a year, it's not really feasible to BIM model all of those. But certainly somewhere like Albert Court absolutely requires it.
Yeah. My question is about how often have you used it since? Because obviously, which you've just answered, which is good. Yeah. Obviously, it's a very prestigious building. So, was it, in terms of sort of application of G5 and how you designed it, are all the meter points actually in each of the individual dwellings, rather than there's no central meter point or meter bank? I'm assuming it's that you're taking everything directly into each individual flat.
The meter box at the bottom. Ted's going in.
Yes. So the majority of the meter locations were in the apartments. However, when we got into that building, the existing meter boxes had been fitted into dumbwaiter shafts and things like that. So we had to take them out and find a suitable solution, which was the light wells at low level, and then we run out of the light wells. At the meter boxes at the low level in the light wells up to the apartments. So there was a couple of meter banks, but predominantly they was in the apartments themselves. I think from memory there was something like 25 meter boxes installed externally.
Right. Yeah, I think the reason for asking is obviously in light of changes coming in G5 and some of the changes which are coming forth in terms of MOBs.
Yeah.
Anything which sits in a meter bank, the sort of pipework from the meter bank to the dwelling then becomes like a private gas network. So is that going to cause more issues going forward, or is that is the management company fully aware of what potentially might change in terms of their obligations moving forward?
Yes, we used steel outlets on them, Simon.
Right. I suppose in terms of lessons learned, how have you applied going forward some of the key lessons to learn from this, and how you've applied it in sort of newer projects?
I think the newer ones, there's a few things that we've looked at. Clearly, there's the application of BIM, whether it's applicable or not, and it's part of our matrix around workload selection, design selection, whether BIM is an option we use. Yeah. The second one would be around customer engagement. I think with an absolute exemplar that there's absolutely no customer complaints on that job whatsoever. It's probably the two ones that hang out. Anything else, Teddy?
I mean, collaboration with key stakeholders is, the game changers for us. There's a residents committee panel that hold weekly meetings that we would attend. They was held in the evenings. The management organisation for Albert Court, we was in constant dialogue with those people, and we supported them with a lot of their other building work that they did. They took advantage of our scaffold and some of our other facilities while we was there to carry out some building maintenance and that. So it was, it's a very collaborative approach, and I think that allowed us to develop a very good working relationship, which one of the challenges with MOBS building is access to properties, and because we had established links with the residents and the committee members, we had very few issues gaining access to the properties, which would be very challenging in an environment like that usually.
Okay, good question coming from Mo, and it was sort of, I suppose the first part is 3D BIM has been a sort of governmental requirement for some time. Has the innovative works you've carried out here been fed back to government to sort of update requirements or sort of give them feedback on what you've done, which actually has made a difference?
But we've not fed back to government. Not sure. Caden may have done. Simon, not sure. Certainly something we can take away.
Yeah, there's an opportunity for you to have a chat with Caden about.
Yeah.
That's brilliant. So just conscious of time. So thank you to Donny.
Thanks, Simon.
For that brilliant presentation. We'll now move on to our second presentation, which is around the asset investment planning project undertaken by National Grid. And that's going to be presented by Neil Tansley, who's the Asset Model Manager at National Grid Gas Transmission. So this project was designed to increase National Grid's asset investment optimization and portfolio planning and management capabilities. So Neil, the floor is yours.
Right, good afternoon, everyone. Hopefully you can see my slides.
That's fine, thanks. And we can hear you.
Yes, excellent. Right, so I'm going to talk very briefly about our implementation project for our C55 investment management system in the run-up to our RIIO2 business plan submission. So C55, you may or may not know, is a product developed by Copperleaf. It's used by a number of utilities within the UK gas, water industry, and our electricity transmission business use it as well. What's different about what we've done, I'm going to talk about, is we've implemented an end-to-end solution across the investment management life cycle, from strategy through to delivery, and ultimately that feeding back into how we make better decisions next time around, moving into our RIIO3 planning process. So it's been a real kind of intention of National Grid Gas Transmission to make sure we've got that line of sight across the whole process end to end. So that's the plan for today. I'd like to say thank you to all the other people who've kind of worked in this project. I'm one very small customer of the process. I'm largely interested in the front end, the strategic optimization bit of the process. But obviously it's involved a whole load of people across our IT teams to integrate it into our company IT architecture, and a whole load of business people involved in developing the processes that makes the system work as it needs to work, moving into our RIIO2 planning period. So I'm guessing most people know who we are, so I won't labour that. It's probably worth mentioning here that the scope of the project was to include all of our assets, both above ground and below ground, so our pipelines network, also our sites database as well. So the plan is that we can model risk both now and in the future across all of our assets, and then ultimately that gives us good information we can actually use to both plan and target investments going forward, both during the RIIO2 period as we kind of move into the delivery, but also moving forward into RIIO3 and beyond as we start to plan for our future and our net zero commitments as well. So a very, very important element of the implementation is that we're trying to create that line of sight through from what we need to deliver from a kind of legislation and compliance perspective, what we've obviously promised the regulator in terms of outputs, but also, and most importantly, what we've committed to do from our customer. So it's a real challenge, this understanding how those requirements at a fairly high level actually translate down into real work that actually delivers those benefits. And as things change, as they inevitably do, work changes, projects slip, we need to do different kinds of work because we get reactive failures, etc., etc. How do all those changes then impact on those commitments we've made to our different stakeholders and customers? So the proposal for all this is to make sure that we've got that line of sight in place so that any change to our investment programme influences what we do during the rest of the RIIO2 period, but also can we take into account for planning of future business plan settlements as well. So people who know a bit about this stuff, not everyone, we've been working for a number of years, not just us, but the GDNs as well, and the ETNs on developing a new way for expressing network risk and ultimately being targeted in terms of how we deliver on our network risk performance, called monetized risk. So monetized risk is a way of kind of bringing all the different kinds of risk, be they safety, environment, availability, reliability, financial, OPEX risk, etc., into a common currency. So we kind of avoid, the historic way that we tend to invest in silos. So now we can invest on the things that actually deliver the maximum benefits across all those categories. And monetized risk is a way of kind of converting risk into a common currency. So a great example of that is, safety risk, where we know the value of a loss of life or an injury from the HSE documentation. We can then translate that to the monetized risk value that gives you value. You can then feed in a cost benefit analysis. So ultimately what we do is we feed all of our investment options into an optimization engine that can then help us determine what's the best blend of investments to achieve our outputs, our risk outputs, our cost outputs at the lowest possible cost, and to manage those changes, as I mentioned before, as they inevitably occur. So obviously this is quite complicated. We have a million assets in our system. There are many different combinations of investments we could do in order to deliver those targets. So we need some support, some IT support to help us to do that. So that's what the C55 solution is all about. Okay, so this is a kind of quick summary of the kind of end-to-end investment management process. So this is kind of what we've kind of embedded within the C55 solution that we've delivered into National Grid. So the two elements at the front end here, in my bit here, the asset risk modelling. So this is basically understanding the risk associated with our current asset base and how that changes over time. So a very important part of that is obviously our net zero commitment. So if we can value the amount of the volume of emissions that come through our operation and through maintenance at different levels of maintenance to be placed with our assets in terms of monetised risk, we can then plan the best investments to mitigate those. And we can do a similar thing for all the different types of risk categories, bring those all together in a way that we can create a plan that ultimately delivers those commitments. So once we've got that plan in place, and obviously we've been through the RIIO2 process now to get the funding agreed for that, we then need to manage that programme of work in an effective way such that those commitments are met and we can take account of any inevitable changes that occur. And that's what I mean by kind of project portfolio management there. So the key elements of this is to make sure that every investment we sanction to be delivered, we've got some effective change control processes in place, and that we can then systemize those changes if they occur, so we can then test the impact of those changes on the overall outcomes we're trying to achieve, and then create that end-to-end kind of cycle that makes us puts us in a better position to ultimately do it better next time around by learning through experience. So really, if people looked at the kind of IAM models, it's about, you know, kind of looking at the whole investment management life cycle and ensuring that we've got full visibility of the impact of any changes before we commit to investments, and we're always delivering the investments that deliver optimum value. Okay, so that's kind of the scope of what we tried to do. So it's very easy to put into a slide, quite difficult to do in practice, because it cuts across pretty much everything we do as a business. So a change anywhere, you know, if we can't get, for example, an outage to do some work on an asset, or we haven't got operational resource to do what to do to support the delivery of capital investment, that could potentially have a knock-on impact on the plan that we need to basically feed back into the C55 solution and then re-optimize it to make sure that we can still deliver the commitments we've promised. And if we can't, we need to do some kind of tactical planning to make up those shortfalls. So as you can see, you know, there's lots of moving parts in all of this, and a systemized approach using a consistent, you know, definition of your asset base, a consistent definition of risk, gives us a really strong foundation to enable us to kind of plan and manage that complex set of interacting parts of the plan. Okay, so in terms of benefits, I've kind of mentioned before, it's about investing across the entire portfolio, kind of avoiding that kind of silo-based investment that we may have done in the past. And it's about making those value-based decisions. So by value, that's quite a loose term. It's about what's important to people. So a key part of this is understanding what's important to our customers and making sure those plans are delivered through the investments we put in place. So we can build what's called a value model in C55, which basically gives you that framework to test different investment options and also the impact of any changes to the investment plan going forward. So by putting your planned work in there, you can then assess how that delivers the benefits you need. And as that work's actually rolled out through delivery, any changes to that plan can again be put back into the system and then tested to make sure that the desired outcomes are still being achieved. And it gives you that ability to kind of manage both your short-term and long-term requirements, looking forward into RIIO3, but making sure you deliver your RIIO2 commitments at the same time. Scaling at reasonable cost. I mean, we've built it up as a starting point for asset health investments, condition-driven investments. The benefit of value framework is you can value anything. You know, people cleverer than I, you can value any kind of investment, be it a land and buildings investment, be it an IT investment, can be valued using the same kind of currency as an asset health driven investment. And then we can pull all that into the same environment and then plan them in consultation with each other. So again, you're avoiding that silo-based decision making. And moving forward, we're going to move more into the world of where we can value kind of like new assets as they're brought into the system as well. And if we need to, you know, modify our network to take account of future requirements, you know, such as hydrogen networks, that can be incorporated into the value framework as well, and different options then tested to get the best and least risky options in order to move that forward as quickly as possible. As mentioned there, there's basically having all this information in the same place gives us lots of potential to make better decisions more wisely, and we've estimated that comes to about 3% saving our investment spend over the RIIO2 period through better decision making and avoiding the implications of unforeseen changes to the programme and slowing down how we deliver that programme. Innovative use of technology, there's kind of a couple of elements in there. Like I mentioned before, we're encompassing the whole investment management life cycle. So we've got that kind of plan, check, review, act cycle going on in the system and embedded in our processes. In terms of delivering the project itself, we adopted what's called a safe agile approach, which gives us the ability to really focus on what was important. So the kind of traditional kind of windfall approach to waterfall method deliver IT projects, delivers, agrees upfront requirements and delivers against those requirements. This is about being flexible. So as business needs change, we can then build in the capability to do that and roll it out quickly. So we get the benefits a lot earlier than waiting a long time to get the system fully implemented. And the result of that is it's delivered. The project was delivered a lot more efficiently. So it's delivered under budget. And we estimate initially there are some kind of reductions in staff time from reporting, and beyond that, there's obviously the potential to deliver lots of savings through doing the right investments and avoiding abortive work, etc., etc. And we'll start to measure that during RIIO2 as we actually start to roll out the programme of work. And last but not least, obviously contribution to net zero decarbonisation. I mentioned very briefly earlier on that one of the things we can do is value environmental risk in the same currency as other kinds of risk, be it safety risk, availability risk. So that gives us the ability to actually kind of build in like an extra inflationary effect into carbon emissions. So future investments that manage those emissions can take high priority in the plan. So that's quite a powerful tool to actually kind of start to build in kind of future requirements as well. So as risk changes over time or future risk changes, we can build that into our planning now, so we can invest ahead of time to achieve our future requirements more efficiently rather than wait until it's too late. It might be more expensive to deliver a particular option to deliver those outcomes. And as I kind of mentioned before as well, the value framework is quite generic. And as things change, if we want to start to consider how a natural gas and hydrogen network can work in combination, we can start to model that within our value framework and start to test different options of achieving that requirement as well. So again, making better decisions, making them earlier, and ultimately delivering them more efficiently for customers. Now I'm about to run out of time, but there's a quick look at what the system kind of looks like end to end. Probably the key thing to mention is one of the big things we had to do is link it into our asset register. So basically, every time our asset register changes, we get better condition information, we build new assets, we can automatically bring that through into the C55 environment and start to do that kind of cost and benefit valuation against those assets. So that's quite powerful, as obviously, we start to improve our data, we start to build new assets that changes the risk profile of the network. We can then test if the things we're doing now are appropriate for that new level of risk associated with the asset configuration that now exists. And a whole lot of work around reporting as well. So obviously a lot of complex stuff in here. Making better decisions is all the key benefit of the system. So by taking the data out of C55, presenting that a way that people can use it as part of the day-to-day business, that can then encourage those better decisions to be made and be able to act ahead of time to manage any risks a lot earlier and prevent any problems that might occur. Okay, that's what I'm going to say. I think I'm out of time. So any questions?
I've got a few, so I'll start off, Neil. It's probably been about 12 months, I think, since the original submission was made. So what's gone on in the last 12 months in terms of the project evolving? Is that very much around reporting, or is it, are there other things that the project has kicked on with? Yeah,
absolutely. I mean, the biggest change has been to start to implement our kind of new business processes to deliver the RIIO2 requirements. I don't know how many people on the call are kind of close to what Ofgem have proposed to RIIO2. There's a lot more focus on well, the transparency of what we're delivering, the costs and the volumes and the outputs. So we've had to build quite a lot of new business processes to make sure that we can one, produce the information that require a level of detail, and again actually start to manage the implications of any changes. So a lot of business process work's gone on to one, get the benefit out of the system, and two, meet those Ofgem requirements. And as you mentioned before, we've done a lot of work in reporting as well. So actually taking the data out of C55, testing it with users, making sure that they can make better decisions on the basis of the outputs from the system. We're also starting to develop it ready for T3 as well. So I mentioned before, kind of starting to value kind of future assets, or so where we're building new assets on the network and it changes the risk profile. That's quite complicated, so we're starting to build that into our value framework as well.
Okay. You mentioned, I think at the start, that C55 is actually used by not just by National Grid but by other networks as well. Have you shared the outputs of your project, and are anybody else actually looking to take on your approaches as you move forward?
Yeah, I mean, Copperleaf are quite active in terms of encouraging kind of their user base to come together. So they've had a number of kind of user events and conferences and stuff like that. And I know NGN and SGN are also C55 users, so we work quite closely with them. We've also done some benchmarking with Cadence as well, who don't use C55, but they're also aspiring to kind of improved kind of asset investment management. Yeah. So there's quite a lot of learning we can get out of using the system that then kind of helps us to test our thinking against other companies who've got similar challenges, and hopefully start to get the whole industry starting to pull in the same direction. Okay. This is what we've chosen, the Copperleaf C55 solution. There are others out there that could be used. It's more the bit that gets the benefits, the process really, that kind of very kind of active change control, understanding what you're delivering and the impact of any changes.
Okay. Final one, obviously, this is very much around sort of asset investment planning and management. I think you sort of implied, because obviously a lot of it's around IT, is there an application for things which aren't just part of the network assets, but other assets or other projects and initiatives that may go on in terms of like new IT systems or other large investments that National Grid is making, that you could use this approach?
Yeah, I mean, absolutely. Our aspiration is, where relevant, to bring everything into the same environment, because there's a big benefit in terms of assessing all investments alongside each other, especially where there are kind of dependencies and overlaps between them. So at the moment, this is asset based for us. It's about kind of gas transmission assets. But there are other companies. I think NGN are using it for kind of IT and land and buildings, like I mentioned before. And if you can value the benefit of doing investment in monetary terms, there's no reason why we shouldn't incorporate it within C55 and treat it exactly the same way as we would a pipeline or a compressor station.
Okay. Conscious of time, so Neil, thank you very much for your presentation and for answering the questions.
Thanks, everyone.
Stop sharing your screen, and then we can move on to our next presentation. So our third finalist in the Project of the Year category is the Gas to the West project, undertaken by SGN Natural Gas in collaboration with Mutual Energy. This is going to be presented shortly by David Butler, who's the director of SGN Natural Gas. So Gas to the West is described as a complex engineering project involving 78 kilometres of high pressure pipelines delivered collaboratively with Mutual Energy, and 142 kilometres of intermediate pressure gas mains, and involved over 500 individuals specialising in their respective field. So David, over to you, and we look forward to hearing all about Gas to the West. David, you're still on mute.
Sorry,
yeah.
still on mute. Sorry about that. Give us just a second to get it going. Thanks very much, Simon. And I'll just get the camera on. Am I sharing the screen now, just to check?
Yes, we can see the screen. We can hear you.
Yeah, thanks. Well, thanks very much for the opportunity to present. As you said, I'm director for SGN Natural Gas. I've been very fortunate to have been involved in this project since its inception in 2015. Firstly, as head of engineering in getting it built, and then latterly since October last year as director. So the presentation will give you an overview of the overall project, and to use a phrase, our pipe dream of bringing gas to the west of Northern Ireland. For many of you across in GB, the use of natural gas as a heating fuel is second nature. Everybody has experienced, but in the west of Northern Ireland, we have no access to the natural gas. with oil and solid fuel being the prime fuels in use over here. The project itself is a partnership between ourselves and Mutual Energy. Mutual Energy looking after the transmission, or taking over the transmission license, and ourselves looking after the distribution, building the overall project. The idea and the purpose of the project is to give consumers in the West a choice of fuels. From a domestic point of view, is to give a choice of fuels for heating their properties and so on. And for commercial businesses, it's giving them a choice of fuel that would allow them to increase their competitiveness in the overall market and so on. A big element as well for us has been an issue of fuel poverty. Northern Ireland itself has a higher percentage of fuel poverty than anywhere else in the UK, but the west of Northern Ireland, roughly 40% of the population come under the designation of being fuel poor. And the final element of it is to provide a new modern system that will allow us to take advantages as we move into a more decarbonised future, either through biomethane and ultimately through the use of hydrogen in a brand new network. To give us some context just of where it is, we're operating across 3 counties in Northern Ireland, a part of Derry, part of Tyrone and all of Fermanagh. In terms of populations, and essentially our licence is a very rural part of Northern Ireland. It makes up about 42% of the whole of the country, but has only about 14% of the population. We've arranged then in terms of the towns, ranging from the very small in Derry Lane up to, for us, the largest in Dungannon at 14,000. So very, very rural population. And we will be bringing gas to approximately 40,000 properties and a series of key anchor loads, industrial anchor loads across. In terms of complexity, it's a very complex project linking together both the high pressure and distribution. We worked very hard at the design stage, coming up with an optimum blend of high pressure and intermediate pressure 7-bar pipeline, bringing gas, building the gas out. Essentially, it ended up, as Simon had said, 142 kilometres of intermediate pressure combined with the 78 kilometres of high pressure. And the plan now is building out the 200 kilometres of distribution. So when we originally submitted this, we were only at the starting stage of distribution, but now we have moved on and we've over 200 kilometres of distribution mains built so far, with another 200 kilometres still to go. A key element of this whole project has been the opportunity for workers. So we've, in terms of the labour, particularly at the transmission and intermediate stage, we had over 500 workers on the project. And what was different and what we brought to the overall area is a lot of the workers in our area would tend to work in Belfast, in GB, in the Republic of Ireland, never working at home. So it was an opportunity for the skilled labour to be able to actually work where they lived. And this is something that's been very welcomed by a lot of the workers who've, for the first times, are actually getting to stay at home while working. It also provides, as an overall project into the future, an opportunity for retraining of workers away from maybe the more construction heavy work into the maintenance and becoming gas safe registered fitters and so on and so on. As mentioned, it's a fairly complex project. I suppose one thing, if anybody knows Ireland in general, but the west of Northern Ireland is a particularly wet place, so significant amount of rain, a significant amount of water courses and so on. So in terms of crossings, we had over 50 river crossings to carry out as part of the overall project between the IP and the transmission. Many of these were involving directional drilling or auger boring or and so on. So quite complex. We also had a series of motorways and major roads to cross, and also cater for future development of a motorway that will be built through the west of Northern Ireland at some point. So we had to take that into account in the design stage. and ensure that if anything we build as part of the project is able to coexist with the future road when it is eventually built. I think this image gives an idea of the scale of one of the crossings, and this was one of the smaller rivers that we had to cross. An important part of this project then is also to provide a clear pathway towards decarbonisation. At this stage, we're putting in a brand new network, fully polyethylene at distribution level. So whatever opportunities that will come through either biomethane or hydrogen, our network will be in a position to be able to cater for it. Our focus now at this stage, though, is on the removing thousands of tons of CO2 because we're displacing the oil, which is the fuel of choice. Working in any cross-country pipeline or any major infrastructure project such as this one involves a lot of work in protecting the environment. So a huge amount of our process at the very start and at the planning stage was carrying out extensive surveys of the various different rivers and ensuring that we carried out fishery surveys, checking that we weren't going to be impacting on any very sensitive areas, or where we were impacting on sensitive areas to ensure that that impact was mitigated. In terms of the terrestrial ecology, again, ensuring that with all the rural wildlife that we were minimising any impact that we would have, and putting together strategies and plans for that. And then in terms of archaeology at a design stage, we worked very hard to ensure that no direct impact on any recorded historical monuments or any historical archaeology was impacted. However, we also had to look during the actual construction stage, on the planning stage, and then into the construction stage, and ensuring that we were able to react to any archaeology that we did come across. And at various different points, obviously, we did come across different parts of different types of archaeology, ranging from small prehistoric medieval settlements. We've come across various different artifacts associated with ecclesiastical sites and holy wells, and these have been documented and protected as part of the overall process. Worked very closely with the environmental and the heritage agencies as part of both the planning and then during the construction phase. To run alongside then the HP and IP was the development of a distribution company, SGN Natural Gas, to bring the gas to actual customers and to get customers connected. We focused, I've mentioned earlier, in terms of the 5 large anchor loads that we connected, and we were able to connect them as soon as gas was available. But we now have gas available to over 20,000 properties, with more coming on stream every week. So the pressure for us, or the objective for us, is to maximise the number of connections that we can make. And as part of this, we have worked very closely with our comms agency to develop a multifaceted marketing strategy, which runs across TV, radio, print media, social media, and so on, and digital advertising. We've obviously also got sort of face-to-face roadshows and so on prepared, and we're very successful in the first year of doing that, though obviously this has been heavily impacted by COVID. So we'll be planning those for once the restrictions get lifted. In terms then of giving something back to the overall community, in order for us to develop both as a new company into an area, and also to give the best opportunity of growing the company, we have to work very closely with the local community and provide a positive engagement between the teams that we have working on the ground, bearing in mind that we do cause disruption as we build out a network, but also working with customers to ensure that they get connected. So we recognise the importance of having meaningful engagement with various different groups, be it the schools, be it local angling groups and festivals and so on. This is a project then that will expand as we continue on. It's going to expand, and hopefully we will get some additional towns connected to the network as it develops. And I'm happy enough to take any questions. That's it from me.
Brilliant. Thank you, David. So the first one is a similar question I asked to Neil. It's obviously been about a year since the submission was made originally as part of the awards programme. What's been the focus of the last 12 months? Is it very much around distribution and trying to get the customers on board as the main sort of creation of the network now complete?
Well, the main parts of the network in terms of the transmission and IP are complete and commissioned. We have gas. We were able to flow gas to the first sections of it in 2019. So the main driver now since then has been connecting customers, be they industrial, commercial customers or domestic customers. Obviously, we have to set up everything else that goes in the background in terms of maintenance, and they're providing the emergency service as well across a very large geographic area. But all that has been working out quite well for us.
Good. Obviously, building a brand new network from scratch, did you have any specific challenges around trying to get the right skills and the right people to actually do that?
Yeah, that's definitely been a real challenge for us, and it's continuing to be a challenge. Certainly at the starting stage, we were relying very much on sort of the period contractors in the area. So there is a particular contractor here who work across the other two distribution companies in Northern Ireland. Our biggest challenge now at the moment, believe it or not, is in terms of keeping that skilled labour. I've sort of mentioned that the workforce is used to travelling, so they're used to working and travelling for wherever the money is. So developing and keeping workforce. We also have competing projects in Northern Ireland. We have a broadband project that is rolling out at the same time, and that is providing competition in terms of the workforce. So it is a definite challenge.
And you talked about all the sort of the engineering challenges in terms of roads, rivers, disused railways, motorways, whatever else. What was the biggest one of those that you had to overcome within the project?
Probably two elements. One is the simple thing of getting land access. The nature of farming in Northern Ireland or Ireland in general is the farms are very, very small. So in terms of on the high pressure side, we had nearly 600 landowners to engage with in the planning stage, and nearly 200 deals essentially to do. So in terms of the parcel sizes, they're very, very small. In terms of the technical side of it, the biggest challenge would have been drilling across Lough Erne. So we drilled in two different drill shots onto an island and then off an island and onto the other side. And this was quite a challenge in that the consistency of the upper layers is essentially like toothpaste. So a real challenge to get that done, getting down deep enough and to getting into the bedrock to be able to get through.
Brilliant. I'm conscious of time like everybody else. So David, thank you for sharing the Gas to the West project with us, and best of luck in a few weeks' time for the final itself. And we'll move on to our fourth speaker for the afternoon. So thank you, David.
Brilliant, Simon. Thank you.
So our fourth finalist is the Green City Vision project, which was undertaken by Wales and West Utilities and Progressive Energy in collaboration with Scottish and Southern Electricity Networks and UK Power Networks. And this project is going to be presented by Bethan Winter from Wales and West. She's the Systems Operations Manager. And in their description of the project, it says it was the first of its kind at the time, being a collaboration between electricity and gas networks to design and optimize whole energy system with the consumer at the heart of it. So I hope I haven't stolen your thunder, Bethan, but over to you.
That's great, thank you. Now I'll just share my slides. Okay, everybody see? Oh, it's popping up now.
Yeah, that's fine.
Lovely, thank you. So yeah, afternoon everybody. I'm Bethan Winter. I manage our control centre for Wales and West Utilities in Newport, looking after the gas distribution network for Wales and the southwest of England. We've got a virtual Future of Energy team, which I'm part of, and as part of that, I've been involved with this project and a lot of others, which are really looking at how Future of Energy changes are going to impact the way that we design, build and operate our network. So the project that I'm talking about today was a whole system analysis project, and we were looking at decarbonisation approaches for Swindon. It's a multi-vector project, so looked at gas and electricity, as you've mentioned, heat, light, power and transport. It was collaborative with GDNs and DNOs, so the Scottish and Southern UK Power Network and ourselves, and Progressive Energy actually did the work for us. And it was looking again at the whole system. So in terms of the context, when we started the project, there were a number of heat decarbonisation pathways on the table. So electrification, decarbonisation of the gas grid, hybrids and district heat networks. We had the 4 FES scenarios, which have been updated since then, but consumer revolution, community renewable, steady progression and 2 degrees. And all of these scenarios and others were looking at solving the energy trilemma, which you don't hear talked about as much today. I think things have moved on a bit, but those are still the key things that we need to solve, which is making sure we've got a reliable, secure supply that's sustainable and also that's affordable for people. Since then, things have moved on. So regional approaches are probably only just really being thought about. The Ofgem single scenario had been put together by gas and electricity networks together, and that was pointing between steady progression and 2 degrees. And then the ENA Pathways project, which is part of the Gas Goes Green programme, was underway, and that seemed to be heading towards a hybrid north and hydrogen north and hybrid south in terms of its analysis of decarbonisation options. So if I go back a step really and look at kind of how we wanted to solve this problem, we were seeing a lot of increased interaction on the gas network between gas and electricity back at this time. We then, and continuing, had a whole host of flexible generators, small generators, which are looking to connect to our system to provide very flexible generation capacity for the times when wind and solar wasn't available because of intermittency. And we also had a lot of green gas in terms of biomethane at the time connecting onto our system. And what that told us was that we had to really stop planning the gas network as a gas network in isolation and start thinking it very much in terms of a whole system. So what you can see here on the top left is green gas. In blue, then we've got the natural gas system that feeds into. And then at the bottom right hand side, you can see the electricity networks. And increasingly, there's overlaps between those. So I mentioned peak generation or flexible generation, which we've got here. Going forward, there's also the option for power to gas, where perhaps you've got an oversupply of wind and solar on a day, and you can actually convert that into hydrogen through electrolysis. So in terms of understanding how that worked, we decided that we would build a model, which we called Pathfinder. We've actually got a Pathfinder Plus version now, but at the time that we did this work, we had Pathfinder. So yeah, and the reason we did that, there was a number of models and research and used by different parties. A lot of the models that are out there, kind of black boxes that you put a lot of data into, it goes off and runs, and then you get some results back. But it's quite difficult to see what they were doing kind of hour by hour, where they were hourly. We were being asked to support external projects. We needed to do our own research and support planning activities, particularly feeding into our RIIO2 plans. And we just really felt we wanted a whole system model. So we built Pathfinder, and it really progressed from 2015 right up until this version in 2018, and then, as I said, subsequently onto Pathfinder Plus. But it's a very detailed model. It's in a spreadsheet. I always say it's not difficult, but there's a lot of it, or it's not complicated, but there's an awful lot of it. I think some people would disagree and say it's complicated as well. But you can see there some of the data that we put into it and some of the things we do with that data. So basically, we start off with demand, heat, light and power, which you'd need for any community, in this case, Swindon. We then look at how that energy demand is going to be met, or what's going to be available to meet it. So in terms of electricity, nuclear, wind, solar, tidal, etc., and in terms of gas, green gas and hydrogen. We then look at those data items over the period of a whole year for every hour. So we're actually making sure that in each hour bar, we can balance the system and that supply will equal demand, or that we've got sufficient energy storage to account for those imbalances. So we simulate everything over the year, and then the outputs that we get will be the storage requirements. We'll know whether we've got over generation capacity, for example, and we'll need to constrain generation. We'll understand about interconnector capacity and where we've got interconnectors, whether energy needs to flow in and out. reliance on each vector, and ultimately cost to consumer. So by understanding how each of these generation types and how often they're going to operate, so what the load factors are, understanding the OPEX and CAPEX associated with them, we can then actually recalculate the energy bill based on that new data and that new scenario. So what Green City Vision did was use that model, but we wanted to look at what the technology trends could be to achieve a 2050 city. At the time, I should also note that at the time we were only looking at 80% decarbonisation. That was the target then. But we wanted to maximise the synergies between GDNs and DNOs or DSOs, so gas and electric. We wanted to inform our investment strategy for RIIO2 and provide evidence for regulatory engagement. We chose Swindon because it's got a reasonable sized population, representative energy demands and progressive local energy policy. And through this work, we did engage with the local stakeholders, so developers, council planners and people like that, just to get an indication from them as to what their plans would be and what their options were. The approach with the modelling, we started off with a National Grid Affairs steady progression model, which kind of assumes that you continue as now, but don't make any major breakthroughs, and actually you wouldn't achieve even the 80% target with steady progression as it stood at the time. So what we did, we used that as a baseline, and then you can see the 4 different areas around the edge that we started. So we said, what if we take steady progression, and then in the case of electrification, achieve the rest of what we need to meet the target just through electrification. On the top right, what if we do it just through green gas? What if we do it just through consumers on the bottom right, or what if we do it just through businesses taking the action? And then we looked at combining those to look at a proper kind of multi-vector or hybrid solution where basically everybody plays their part and everybody does absolutely what they can to achieve the limit. And I don't think I'd be giving anything away by telling you that, as you would expect, really, the most effective way we found for decarbonisation to happen was very much that every vector and every consumer out there does have to play their part in this. In terms of the information that we get out through using the Pathfinder model, we could look at what the 2018 data was for a network, so the average demand, peak demand, which is very important when you're looking at investment and increasing capacity on that network, inertia, which is becoming important for the national grid, so looking at how stable the electricity system is, because with more renewable generation, you actually lose some stability. And then the peak demand change, which tells you the investment you need. All scenarios indicated an increase in peak and average demand for electricity. I think even if you take away the uncertainty around heat, the addition of electric vehicles is of course going to have a massive impact in terms of what the electricity networks need to do. Average increases of 50% until 2050, but up to 100%, and grid inertia reduced in all scenarios. So again, really highlighting there that new services might be needed for the electricity networks so that they've still got a stable network to operate. In terms of the gas network, there was an average reduction in gas demand of 35% over all those different scenarios that we looked at, but there wasn't a single case where you could say you would decommission the gas network altogether. And the reduced demand is very dependent upon home efficiency gains. So again, I won't go into a lot of detail today, but we really did look at how much investment would consumers have to make in their homes, in terms of financial, for insulation and all those sorts of things. But also, if you really wanted to push homeowners to be the ones that were really supporting decarbonisation, then what level of comfort would they need to lose? So how much cooler would their homes need to be? In terms of the key conclusions, I'm really sorry, I have really rocketed through, but very conscious of time. The key conclusions were that both networks would be necessary for compliance. Like I say, there wasn't a case made for either to be decommissioned. And the other thinking that we had was that supply-driven strategies were deemed to be more deliverable than demand-driven strategies. So again, we could rely on consumers to sign up for insulation, to operate their heating systems in different ways, to look at maybe not using electricity when demand is low, for example. But we felt that really requires not only a massive buy-in and investment up front, but they also would need to carry on behaving like that. So you'd need to really get that buy-in from the consumers. In terms of a reliable option, we felt that it was best to start on the left here with low carbon gas, which we're already doing, and consumers aren't even aware that they're operating on biomethane already. New home efficiency and hybrids was the next one, followed by retrofit home efficiency and heat pumps. Obviously, retrofitting is far more difficult than new homes becoming more efficient. And finally, then reduced consumer comfort. And I think that was very much a last resort because of the potential impact on health as well. So I have absolutely raced through that. But yeah, has anybody got any questions?
Brilliant. Thank you, Bethan, and thank you for sticking to time. You talked a number of times about what the network was like at the time of the project. So you said you had a lot of sort of flexible small generators coming on board, biomethane, potential for power to gas. How much has that changed over the last couple of years?
So biomethane probably hasn't increased significantly. I think there's been some uncertainty about the renewable heat incentive, but that's now been replaced by a green gas levy, so we're expecting that to pick up. Having said that, in our network, we have got a waste-derived biomethane plant, which we're looking to connect. So the technology is advancing all the time. And again, that technology is looking at ways of recycling or turning into gas black bin bag waste, which will actually be, excellent for solving another problem as well. Flexible generation, that has absolutely continued to take off. So I know I was talking to SGN last week and they said they've connected 53 sites this year. I think in our network, Wales and West, I think we're also up at kind of, I can't even remember the numbers, but I think we've got about 40, 50 altogether. I think we've got another 30 kind of waiting in the wings. And then we started looking at the electricity capacity markets to see what auctions people have secured electricity capacity for. And we can see we've got another 30 or 40 waiting there. Wow. So a project we've just done now is looking at how we forecast those generators, bearing in mind how responsive they are. So that's actually, if you think of this as being one of our older innovation projects, literally last week, I'm kind of closing down one now, which is looking at how we operate these things in real time.
Yeah. Okay. Obviously, in terms of the timing of this, how did you, as Wales and West, but also do you know if the electricity networks, in terms of SSEN and UKPN networks, take some of these findings and to help inform RIIO or your RIIO 2 planning?
So yeah, so this was a significant input into our RIIO planning. I think this, in conjunction with a lot of the other innovation projects that we were doing, this kind of brought everything together, if you like. So we'd done an innovation project in Bridgend, which looked at hybrid heating systems and how if you have a heating system which is gas and electricity, then actually you can really optimize it to use whichever is greenest at the time, but also to avoid things like network constraints, where you switch it over from one vector to the other if you've got a problem with the network itself. So all that and this all very much fed into, effectively, we had a whole chapter which was how Wales and West felt it was going to make itself ready to facilitate what became then net zero by 2035.
Okay. Final one then, you talked, this is based on the Pathfinder tool and you now on Pathfinder Plus. So what does Pathfinder Plus do that Pathfinder didn't?
So there's a few things, I think, and a lot of that was the learning out of this project, really. I mentioned system inertia as being something that we looked at, and that grid stability. So that was a calculation that in this project was done offline, but which is now done online as part of the Pathfinder tool. One of the other things was to add in your kind of diesel and petrol vehicles. So we hadn't included those in Pathfinder in the beginning, because when you're looking at kind of net zero, why would you want to think about diesel and petrol? But in terms of looking at the benefits you're getting from a new scenario, again, offline, we were calculating how much are we improving the situation by taking those diesel and petrol vehicles off the road. So those were a couple of the sort of examples of things that we've added in.
Okay, brilliant. Again, conscious of time, but so Bethan, thank you very much for sharing the Green City Vision project with us, and best of luck in a few weeks' time.
Thank you.
We'll now move on to our final speaker for this session. So the final presentation is the OSS project, which was undertaken by Lagoni Engineering in collaboration with National Grid Gas Transmission. So I'm delighted to welcome Thomas Olsen, who's the Managing Director of Lagoni. And this project, as described in your entry, is described as a disruptive cyber defence and control platform enabling digital transformation in gas networks. I'm intrigued to find out what are you going to tell us. Thomas, over to you.
Thanks, Simon. So it's always been a while since we entered that one. I think it's nearly a year and a half ago. So I'll try and recap just where we are, and also probably more importantly where this project has taken us since we submitted and since the conclusion of it. But as Simon said, I'm Thomas Olsen. I'm actually now also head of cyber and digital. We were acquired by a company called Belcan International last year, so things have certainly moved on. nonetheless, we're still on with this. So just very quickly on the backdrop on this project. When we originally set out, I was lucky enough to be part of this project, sort of start this project with National Grid Gas Transmission, where we're looking at really trying to understand the cyber defense requirements within the compressor stations in the for National Grid Gas Transmission. And one of the key things that's come out since we started this project is very much around, the evolution of where we want to be as a country and as a global, globally in terms of smart technologies and being able to connect more and being able to analyze and digitize and use all sorts of fancy AI and machine learning technologies to improve. But nonetheless, the government has sort of come up with some quite punchy statements around the types of savings that they expect to see through the use of these technologies and the application that's required in order to decarbonize our networks as a whole and to create this smart utility system. And with that in mind, what we're looking at was very much the status quo of sort of realizing where we are in the ecosystem in the life cycle today, and really understanding that a lot of the technologies that we're dealing with that controls and operates our networks very much still sitting sort of in the third revolution era, built in the 80s, 90s, early 2000s, if you like. Not much has come online that is later than that, and we're now seeing that sort of challenge within the gas transmission system and also in some of the distribution systems, both in water and electricity and also in gas. So it's very much this sort of the aspiration of getting into this fourth revolution where we can connect things. The key challenge, though, for doing that, is very much around the cybersecurity and the challenges around this to try and protect our systems, our gas networks, in a way that allows us still to be cost effective, that allows us to operate and connect our systems in the future and going forward from where we are today. A couple of key points that we looked at in this project early doors was very much what are the challenges and how can we mitigate them and how can we be innovative in trying to combat this. So very much when we're dealing with we talked about earlier about some IT systems, we also very much rely on the operational technology systems and the cybersecurity of those. The challenge is that they are a lot older. The challenge is that when we change one of these components, it very much has a knock-on effect of the others, and then all of a sudden you're into some very expensive replacement programs. And also that we have built them over decades, so we don't have the standardization. So we want trying to combat those, and that was really what kicked off the project off, at least our thinking. So the project itself was focused around to try and deliver a cyber enhancement to an existing infrastructure up at a gas compressor station in Scotland. Our focus was very much around, looking at the threats, looking at what we can do, and trying to inject this incorporated within the existing infrastructure at critical national infrastructure level. So there are some key security requirements that we had to look at. At the same time, we had a piece of legislation that sort of interrupted us a little bit, came out, and we needed now to look at this. And certainly the operator of essential services sort of got born earlier at the beginning of the project, and very, very much regulated by Ofgem and BEIS, and NCSC. So all of a sudden there are some other stakeholders that got involved. But ultimately, this is about cost reduction, be effective to introduce this so we can enable the digital transformation journey and get data out of our assets, control them better, manage them better, and ultimately drive efficiencies and drive toward net zero. So that was very much the scope of the idea of the project at the time. That was evolved over 3 years, 3.5 years. And really what we were looking at was some of the really old systems and how can we improve that. So the project itself became known as the OSS Project. It was sort of first of its kind in terms of the way we looked at retrofitting security into these industrial systems, and being able to put them in without having to replace an entire infrastructure and have a lot of downtime. We did that by sort of looking at it in a sort of a modern way, a little bit of the same way that we would look at applications on a mobile phone you know, back in the good old days, we had these Nokia phones where you had to install everything on every single device, every single phone. Now we have a smartphone where everything is centralized and using of deployment technologies. So very much that ethos was what we tried to adopt. That's known as the Docker principle of containerization. So we're able to install a lot of these that's currently hardware ideas or hardware concepts. So SCADA servers and things like that can now be created as a software application, like an app on a phone. And because the technology's moved on so far from when we originally put it in, we've been able to sort of make it a lot smaller, much simpler, and a lot easier to protect. So very much this was sort of the drivers for the solution. So it became upgradable and maintainable independently of the systems underneath us, the control systems, etc., different vendors. But ultimately, we could apply a sort of a common strategy for an entire fleet that tied into the overall cybersecurity strategy. And we moved a lot of things forward with this project as it's turned out in terms of thinking in industry and also application on different types of architectures that we're now installing. So specifications have changed in very much in line with the thinking from this project. So we've seen some really positive steps from this, but ultimately it provides sort of this idea of centralized control and ability to administer these applications and future-proofing it, so that if we want to do things in the future that we haven't thought of yet, we don't have to go out and rip everything out. We just deploy a new application, obviously under the right standards and G17 and G35 processes. But that's really where we're trying to get to. So just very quickly, the outcome of where we got to. We started looking at this on a single compressor station. It's been running now there for 2 years. What happened since we submitted this application is that it's now been part of the rollout program for T2 for National Gas Transmission. So this is the principle that's being used, which obviously we're extremely proud of because it's taken a long time to get there. But really the adaptation of this thinking and this technology can now be applied by anyone and others, not just ourselves. So it's sort of broken, it's disrupted the way that probably traditionally we would have delivered these projects. It's a modular piece of software, effectively a modular software application. And we can use existing or off-the-shelf hardware. So it sort of, again, breaks this idea of having to go to a specific vendor, and all can be controlled. But it's all about enabling this real-time data flow out of these facilities, so we are able to do some clever analytics in the future on proper real-time data. We had a huge cost because we made it smaller. It was simpler to install. We had some really significant cost reductions, and also the target was to increase the security scoring on these facilities along with the compliance, and we definitely achieved that. But ultimately, what it comes down to is when we compared the submissions for RIIO T2, then there were some significant savings per site of doing it this way versus the traditional way. And the sort of the remit now is that this is the way it's going to be done during T2 and T3 over the next 10 years to replace that sort of infrastructure and inject that infrastructure. So we're very, very lucky to be part of this project, and I think it's been an excellent showcase certainly for the security industry to see how things can be done as a service rather than as a product. And obviously it's been exciting to be part of this journey. So I think I'll hold it there, Simon. I'm happy to take any questions.
That's brilliant. Thank you, Thomas. Question for me in terms of, this is obviously being applied initially to compressor stations. Can it apply to other assets as well? Or
yes. So the answer. So I think we talked about this when we presented this at the actually live conference a couple of years ago, early doors, where we're looking at that. So the answer is yes. We managed to get it down in size so that we can now use this principle for others. And in the last 6 months, we've actually been working with the electricity side as well to apply the same principle. We've got a couple of in-flight projects with some test facilities to really try and apply this in their domain. And the only difference is the types of systems that we are connecting to. the security principle is still the same, and the idea of this being able to put this into a smaller substation in the future, it's very much very exciting.
Brilliant. So you talked about obviously the rollout's going to happen, or started to happen as part of T2 and T3. Is that just initially in compressor stations, or are you rolling that out into other assets, or is it too early to say in terms of the detail, all the detail at the moment?
The commitment at the moment is for compressor stations. That's the specification that we've seen being changed. So the current architecture shows this concept, or this not concept, but this solution being applied. So we're very much seeing that this being a compressor station to start with, and then see where it takes us. But there's a very good place to start, I would suggest.
Definitely. And then the final one is, does it have an application across the GDNs as well? And is that sort of your next port of call?
Yeah, so we are looking at that already. We've had some conversations with some of the GDNs already around this application and being able to use this at AGI level, and sort of looking at how we can improve the data extraction on a secure perimeter, if you like. So it's certainly something we're into at the moment.
Brilliant. Okay, so once again, thank you, Thomas, for joining us this afternoon, and like everybody else, best of luck in the final in a few weeks' time. So that just leaves it to me to wrap up where we are in terms of today's session. So I'd like to thank all our speakers for their engaging and insightful presentations. Thanks to both the IGEM and the EUA team, Freudian slip, for promotion and delivery of today's event. The next awards webinars, as you can see in the chat, are next Tuesday. So we have the Safety Award, where we'll be looking at showcasing the I think it's the 3 shortlisted finalists in the safety category, and the following Tuesday we'll be looking at the Customer Service Award. And most importantly, the actual final itself is going to be held virtually, and that's going to be on Tuesday, the 18th of May. To book your place for that, if you just go to www.gasindustryawards.com. The event is going to be compared by television presenter Dallas Campbell, who's actually going to be live in IGM House, which sounds to be an interesting challenge for us all to do that as a hybrid event. And we will also be featuring this year's guest speaker is Jonathan Brealey, who's obviously the CEO of Ofgem. So obviously book your place on the Gas Industry Awards website. We hope to see you all again soon at either next week or one of the future webinars. Thank you all for joining us, and stay safe.